Hi, in previous video we seen what is division clustering, the factors affecting division clustering, Lance Williams, and agglomerative for algorithm for agglomerative hierarchical clustering. Here we're going to see the algorithm for divisive hierarchical clustering. In this algorithm, the steps involved in divisive hierarchical clustering. In line 1, we start with all the points contained in the maximal cluster. In this line, the bisecting k-means approach is used to determine the uniform splitting mechanism to obtain C1 and C2. The heuristic mentioned above and choose the cluster with a higher square error for splitting the next parent. The steps are run repeatedly until the complete dendrogram has been constructed as mentioned. We can use threshold to handle noise during the construction of the dendrogram. What is the algorithm of basic divisive hierarchical algorithm? Start with the root node consisting all the data points. Repeat the same part in step 1. Split parent node into two parts C1 and C2 using bisecting k-means algorithm to maximize Watt's criteria. To maximize Watt's distance. Maximize Watt's distance W of C1, C2. Construct the dendrogram among the current. Choose the cluster with the highest squared error until singleton leaves are obtained. Repeat the same step 4 until the singleton leaves are obtained. It is the algorithm for divisive hierarchical clustering algorithm. It is the algorithm. Next, minimum spanning tree based clustering. In a weighted graph, a minimum spanning tree is a acyclic subgraph that covers all the vertices with the minimum edge weights. Primes and Kruskal's algorithm are used for finding the minimum spanning tree in a weighted graph. In Euclidean minimum spanning tree EMST, here EMST is remember EMST is minimum Euclidean minimum spanning tree. The data points represent the vertices and the edge weights are computed using the Euclidean distance between the two data points. Each edge in an EMST represents the shortest distance between those 2 points. Using the EMST, a divisive clustering method can be developed to remove the largest weighted edge to get 2 clusterings and subsequently removes the next largest edge to get 3 clusterings and so on. This process of removing edges from EMST gives rise to an effective divisive clustering method. The major advantage of this method is that it is able to detect clusters with non-spherical shapes effectively. The basic EMST clustering method proceeds by taking a user-supplied parameter k, where the edges present in the graph are sorted in descending order. This is followed by removing the edge with the top k plus 1 weights one by one to get the k connected components. This is similar to the process of divisive clustering, where finer clustering partitions are obtained after each split. Subsequently, we can also use the EMST to build a clustering algorithm which continuously prunes the inconsistent edge present in the graph. An inconsistent edge is one whose edge weight is much higher than the average weight of the edge in the neighborhood of that edge. Algorithm describes the minimum spanning tree based clustering algorithm that was originally proposed by Zhang. This is minimum spanning tree clustering. Next. algorithm for minimum spanning tree in divisive cluster. Create the EMST using prime Kruskal's algorithm on all the data points. Repeat the same step 1. Remove edge with the highest inconsistency measure until no more inconsistency can be removed. Until the process 3, no more inconsistency will be removed. No edges should be there. Next. Here we will see other hierarchical clustering algorithms. There are more algorithms which is similar to agglomerative and divisive. The agglomerative divisive hierarchical method clusters are successful in capturing convex shaped clusters effectively, as mentioned above and in previous slides, in previous videos. Agglomerative methods, especially single link and complete link, suffer from the chaining problem and are ineffective at capturing arbitrarily shaped clusters. Hence, to capture arbitrarily shaped clusters, algorithms such as Q and chameleon have been proposed in the literature. Some of the popular extensions of hierarchical algorithms are here. Q, clustering for Q, the acronyms clusterings using representatives in an algorithm which incorporates a novel feature of representing a cluster use a set of well-scattered representative points. The distance between two clusters is calculated by looking at the minimum distance between the representative points chosen. In this manner, Q, which means clustering using representative, incorporates features of both the single link and GAC hierarchical clustering methods. Choosing the scattered points help Q capture clusters of arbitrary shapes also. In addition, Q employs a shrinking factor in the terms in the shrinking factor in the algorithm. When the points are shrunk towards the centroid by a shrinking has a great effect in the case of outlier compared to normal points. This makes Q more robust to outliers. Similar to this approach, an algorithm called ROG was also proposed to handle categorical data. The algorithm uses the concept of common links and determines the Jaccard coefficient between candidate clusters for hierarchical clustering. Chameleon. Chameleon, you already know it's an animal, not reptile, uh, but here it's another type of other hierarchical clustering. Chameleon is a clustering algorithm which uses graph partitioning methods on the k nearest neighbor graph of the data. The initial partitions are then used as the seed clusters for the agglomerative hierarchical clustering process. This algorithm uses two metrics based on the relative interconnectivity and the relative closeness of clusters to merge the clusters. This metric captures the local information of the clusters during the clustering process, thus enabling this algorithm to behave like a dynamic framework. Chameleon is one of the best hierarchical clustering algorithm and is extremely effective in capturing arbitrarily shaped clusters, which is primarily due to dynamic behavior. A detailed comparison between these clusters and is the results of for synthetic datasets, results of Q and Chameleon or for synthetic datasets, the clusters of varying shapes can also be found. Next, cobweb and self-organizing map SON. This is conceptual clustering algorithm that works incrementally by updating the clusters object by object. Probabilistically described clusters are measured as a tree to form a hierarchical clustering known as probabilistic categorization tree. It handles uncertainty associated with the categorical attributes in clustering through a probabilistic framework that is similar to naive bias. The dendrogram in this algorithm is also called a classification tree, and the nodes are referred to as concepts. Self-organizing maps were developed on the same lines of artificial neural networks and are useful for hierarchical representation. It is an efficient data visualization technique similar to k-means. Data points are assigned to their closest centers. The difference arises in the centroid update set where when a centroid is updated, those in its neighborhood which are close to this centroids are also updated. The final output is an SOM neural network which we can be explored to understand the relationship between different objects involved in this clustering. These are the other types of hierarchical clustering. Thank you.